I'm really amazed because what we're doing today with climate, and it's one of the solutions I see to averting this catastrophe, is taking it to the streets. When you think about Extinction Rebellion and you hear what they're talking about, they're not really saying we are protesting. They're actually saying we're rebels, we're in rebellion against the government. And what are the arguments? The arguments are that actually government, whatever you might want to think of as government, has broken the social contract to act on the climate, and I would add then the ecological emergency, because for me the two go together. So in the UK, the Extinction Rebellion has got three demands. First of all, governments need to tell the truth about climate and ecological emergency, and that's what we're going to hear from Vicky, particularly about, well, what are the facts that we can rely upon? The government has to act to reduce greenhouse gas emissions, and that goes hand in hand with halting the loss of biodiversity. You can't have missed, perhaps many of you, the headlines about the loss of many parts of the Amazon because of burning, but all over the world, every day, we are losing biodiversity, and that is absolutely critical because one of the solutions is going to be around the ecological regenerative power of the biosphere. And the third is that government must create solutions that are led by decisions from citizens. Decisions which may be in citizens' assembly, or on climate, on ecological justice, but on all the facts that pertain to the emergency that we're in. What I see is very interesting because at root the demand is a very positive vision of democracy. It goes way beyond politics and parliaments. And what I like is that it aligns with a kind of real meaning of what democracy is, where ordinary people, you and I, can really help putting evidence together. We can decide on the kinds of policies that are needed. And what's very interesting is that we're not trying to bring government down, but to radically change the way in which solutions are put together and the way in which they're arrived at. So worldwide, we see thousands of people who are really taking on this discussion. They're sort of doing civil disobedience in a quiet way in some places, and this is a manifestation of the pervasiveness. It's not about a road here and a power station there, although those are very, very important, but it's very much about the fundament of how we live our lives. I can tell you that in the process of stopping the Lamu coal-fired power plant in Kenya, there was as much passion about why we needed to stop that as there would be in any European country. The consequences of having coal were absolutely manifest. And we'll come back to that in the context of the development agenda and how really climate change is affecting very, very many people. And the development agenda as it currently sits is not addressing what they need. So citizen assemblies are part of the package of solutions. So can we avert disaster? Maybe, but we have to do some things in very different ways. So what they have shown already in places like Canada, Denmark, Kenya, Ireland, many other places around the world, is that people who come together in citizens' assemblies can really weigh evidence, they can engage in careful deliberation and make fair choices that really do look not only for today, but also for future generations. Climate justice for the future. They can take on big questions and really get involved in the kind of broader decision-making. More importantly, run well, they can be inclusive, both in terms of who actually is part of it. They can be very transparent. And more importantly, they're unencumbered by a kind of parliamentary process. So what we see, of course, is changes happening everywhere. And there are multitudes of things happening around the world, but in an intensity that actually we haven't seen before. One of the things I do is monitor through social networks all the different ripples of activity that are happening. And it's absolutely clear that people are actually thinking about different ways of going forward. So we're building on a kind of momentum. What's happening in Hong Kong didn't come out of nowhere. It came out of a long tail of all kinds of conversations happening around the world. And I think you would hopefully agree with me that Greta Thunberg is somebody who's a manifestation of that conversation, albeit in some cases quite surprising about the sophistication of argumentation that's used. But what's really clear is that people are saying, yep, this isn't a climate emergency, and to avert the catastrophe that we can see happening before our very eyes, especially if you're living in the developing world, it's not just an intellectual exercise. It is actually about our futures. As some of you know, I live part of my time in Kenya, out in the bush with the Maasai tribe. And I interact a lot with people in the city, in Nairobi, and on the streets, and as I say, out in the bush. And what was interesting there was that in the city, people who were demonstrating on Climate Action Day were met by a crowd around them who were saying, actually, our real challenge is about getting food on the table for our families. But out in the savannah, out in the Rift Valley, when you talk about climate change, it's real. Cattle are dying, food crops are not coming forward. And so climate change has a real visceral meaning for people's everyday lives. Interestingly, when we saw the ban coming in for single use of plastic bags, which uses a lot of oil and in its sense is contributing to the emissions that are coming out, people actually got that connection. So in the city, single-use plastic bags and the ban that went with it was to understand very easily. Whereas out in the bush, where there aren't so many, the connection was not so clear. And so what this tells me is that when we try to break the silence on climate and the climate emergency, we need lots of things to happen. First of all, we need the connections to be made clear between everyday human activities and what is actually happening behind the scenes. And that needs to be fully explained, not in a neutral way. Of course, nothing about climate is neutral, but in a clear way. And denying those connections is really not a good thing. However, what you see is that somehow in the wider public setting, some of that conversation is being discouraged because, in a way, people fear expressing unpopular views. Depends where you are. Secondly, the climate emergency needs to be discussed everywhere. I mean, in the media and everywhere. Because, unfortunately, people don't believe that it's important unless it's being discussed. This is a bit like the bystander effect. So there's an accident, there's a fire happening, and people stand by. And you wonder, well, why aren't they phoning the fire brigade? Why aren't they doing something? And of course, in many parts of the world, particularly in the developed world, there's a sense of, oh, well, somebody must have already taken care of this, so I don't need to do it because somebody has already done it. Well, it's not quite like that with climate. But there is a challenge in the bystander effect being part of our psyche, which means, well, authorities know about this, so they must be doing something. The question is, are they? Probably not, or not enough, and not enough in the public setting. So people don't know about what it is. So we really need to sort of, in a way, create the metaphorical sirens that tell people, yes, this is an emergency, we need to do something. And then in the end, we need citizens' voices who are really experiencing climate change, particularly, to be amplified. We need to hear from the front edge of where climate is really biting into everyday life. The University of Colorado did an analysis of the UK newspapers, and it was extraordinary because in April, earlier this year, there was more coverage on climate change than in any previous 2 decades, apart from the Copenhagen conference and Paris. When you interview young people between the age of 18 and 24, it is apart from Brexit, it is the most important issue for them. It's their greatest concern. So let's think about the evidence for action, because one of the hallmarks of the way we do things, in a sense, and to deliberate on ways forward, even though it's highly complicated, is to think about the evidence. And I'd just like to read you very shortly what Greta Thunberg said when she went to the Congress, not what she said in the UN, which was a highly emotive speech, I think warranted, but what she said to the Congress in the US was very, very insightful. So let me just read that. She said, "And yet, wherever I go, I seem to be surrounded by fairy tales. Business leaders, elected officials, all across the political spectrum, spending their time making up and telling bedtime stories that soothe us and that make us go back to sleep. These are the feel-good stories about how we're going to fix everything, how wonderful everything is going to be when we've solved everything. But the problem is not that we lack the ability to dream or imagine a better world. The problem now is that we need to wake up. It's time to face the reality, the facts, the science. This is above all an emergency, and not just any emergency. This is the biggest emergency humanity has ever faced. Stop thinking that you, your business idea, your political party or plan will solve everything. Some of you may have heard that we have 12 years, as from January 2018, to cut our emissions of carbon dioxide by half. But I guess that hardly any of you have heard that that's for a 50% chance of staying below 1.5 degrees centigrade. And having spent part of my time when I was in the UN working on what was called the emissions gap report, it's very, very true. It's like having a bank account and where you're basically running down your capital. We have only so much carbon dioxide emission equivalents that we can release into the atmosphere. And after that, it's kind of like all done, thank you very much. And the models that we have, and I'm sure Vicky will talk to us a lot about that, are at best our kind of best estimate. But in the end, reality is telling us that things are speeding up. And would you like to take a risk on, let's say, putting your child on a bus if you had a 66% chance of it crashing and your child dying? No, of course you wouldn't. So this idea of risk and where it's coming from has kind of been sent down to the level of it's going to be okay, we're going to find technologies to solve the problem. But what this evening is really about is about the psychology and about the justness of what is happening around us. So we're going to have the facts given to us as we best understand them from the scientific community. And they are very alarming, but we're also going to look at our own position within that to see, well, what is it that we should expect of ourselves? So who's doing what? We are very clear that we're getting reports that tell us about what's happening in the Arctic, the Antarctic, the speed of things. We have political processes, the Talanoa dialogue, which is a very participatory process. We have the UN framework. We had the meetings in New York last week. And we've got the Climate Action Summit outcomes, people promising to do things and involving everybody and so on. But at the end of the day, it boils down to groups, communities, people we know in all corners of the world, all trying to do their bit, trying to find their own pathway to change. So from farmers in Kenya to pastoralists to indigenous peoples in Amazon, we all have our own struggle. And the response, when you speak to many of those peoples, is not to look to government, but actually look to the natural world, to look to there for solutions. Because in the end, that is the rudimentary basis upon which we will survive on the planet. But if you're an acute and aware of what is happening around you, you will see changes in all aspects of biodiversity. I mean, Sir David Attenborough showed it beautifully in his documentary about climate change. But you yourselves can do this in your everyday practices, where you walk, who you hear in terms of bird life, and so on. And what we see is that we are destroying our ecosystems. So that means that every one of us can do something to make a difference in the possibility of having nature provide resilience and some of the solutions. So can we, at the same time as having big government coming in and potentially addressing or redressing some of the unfortunate decisions about subsidies and so forth, can we match that with our own contribution to taking care of nature, of biodiversity, and the way in which we look to nature to solve the problems, and in fact produce outcomes that will improve our own prosperity and well-being? So with that, I won't take any more time. I want to introduce one by one, but right at the very beginning, our three wonderful and engaging speakers, three professors, Vicki Pope, formerly at the Met Office and now at University College London. And she's going to give us the latest update on the climate models and how they'll help to guide actions. Then we have Damian Short. He's from the School of Advanced Study at the University of London. He's going to speak about the legislation, ecocide, very strong words, and explain some of the history of where that's coming from. And then finally, Beatty, who's going to come with the psychology of what this all means and taking us towards action.
I'm going to talk about the models that we use to help us say what is happening with the climate. But to start off with, I wanted to show you some of the evidence. And I'm not going to show you lots of pictures of different types of evidence of what's already happening in the climate. Because people talk about temperatures already increased by 1 degree. But a global average of 1 degree change in temperature, what does that mean to anybody? It doesn't sound like very much. But this is what it means in practice. So this graph here, you can see, goes from 1990 up to, sorry, is that 1980, sorry, up to, so I'm standing right at the side here, up to 2015. And so it's a fairly short period, but it's showing you the changes in extreme events. And to give you a baseline, we've got at the bottom here, things like earthquakes and tsunamis, which obviously are not affected by climate change. And they vary from year to year, but they're pretty much the same all the way through. But when we look at all the things that are affected by climate change, we're seeing dramatic changes. So we've got meteorological events, which is tropical storms, extratropical, so that's tropical storms, and and then also storms, extratropical storms are the storms that affect us in Europe, and then other types of storms as well. The hydrological events, so these blue bars here, are increasing massively. So this is talking about flooding, for example. So, we're already seeing increases in flooding because of climate change, even though the temperature's only gone up by 1 degree. And then finally, we've got what we call climatological events, which is extremes of temperature and drought and wildfire. And again, we're seeing increases there. Not quite as large, but nevertheless, measurable increases. And if we actually, oops, it's not moving on, that's it. When we look at all of these events combined, more than 60% of the extreme events studied to date were made more likely or more severe by man-made climate change. So we can look at all different types of climate-type events, and we can see the impacts already. When we combine, so you can't say an individual event is caused by climate change, but what you're saying is the likelihood of it being severe is increased, and that's the way that climate change tends to be manifested. It's manifested as individual events rather than a specific change in temperature, which you might not notice because you can get obviously a change in 3 or 4 degrees or even more from one day to the next. But it's that combined effect. So we can see those things happening. So how do we actually understand what's happening to the climate and predict what might happen in the future? Well, we use climate models to do that because obviously the data can tell us a lot about what's happened in the past, but unless we have some means of doing this and we use our knowledge of the real world and we basically manifest that knowledge in a virtual world on a very large computer. The Met Office actually has one of the largest supercomputers in the world in order to do this and to do its weather forecasting. So these are the processes that are particularly important for climate. So the whole thing is fueled by energy coming from the sun, so the ultraviolet radiation coming in from the sun. And I'll talk a bit more about this. There's the water cycle, which cycles water through the system. Water is obviously vital to life, but it also has a big impact on climate. And then the general circulation is how the winds are blowing and the currents in the ocean, which redistribute the heat around the world, as well as obviously giving us our weather. And then what we're doing to change that. So we're looking at a very balanced system where everything balances up. And by changing some element of that system, which in this case is the greenhouse gases, that is changing that balance. So the energy cycle. So we've got radiation coming from the sun, this represented by these arrows here. Some of it's reflected by clouds. Some of it is reflected by the Earth's surface. But a lot of it gets absorbed either in the atmosphere, in the clouds, or in the Earth's surface, and that's what warms up the planet. So you get obviously more warming at the equator, very little warming at the pole where there's much less sunlight. And then that warm Earth then re-radiates heat out again in the form of infrared radiation at completely different wavelength. And that some of that radiation also gets absorbed in the atmosphere and then re-released into space. The absorption in the atmosphere could be by clouds. Obviously, a cloud can stop the heat from escaping, but also by water vapor. So the water in the atmosphere absorbs some of that radiation. But the thing that we're concerned about is the carbon dioxide. Now, the amount of carbon dioxide in the atmosphere is a lot less than the amount of water vapor in the atmosphere, but it's because it absorbs at a different wavelength to the water vapor that it has quite a big impact. If it absorbed at the same length of water vapor, it would be swamped by the impact of water vapor. So when you change the amount of carbon dioxide, it changes the amount of heat that's trapped in the system. And essentially, the greenhouse gases act like a duvet. We talk about it as greenhouse, but actually it's a bit more like a duvet, really. It's trapping heat in the atmosphere. It's really important that we have those greenhouse gases. There would be no life on the planet without them, because the average temperature would be minus 18 degrees. Everything would be frozen. So it's, those greenhouse gases are important. They give us an average temperature of 15 degrees, which gives us this very balanced system which allows life to thrive on the planet. But what we're doing is changing that balance, and by changing the temperature by a degree or two, or even more if we don't reduce our emissions, that changes the balance. So the next thing that happens is the water cycle. So as the temperature increases, so when you have warm temperatures, basically water will evaporate from the surface. You'll get water stored in the atmosphere. So that water vapor comes in the atmosphere from the surface. It tends to rise up. As it gets higher up, it's colder, and so it condenses to form clouds. When those clouds get very heavy, then the water droplets can become rain or snow, and so you get this water cycle. And as I mentioned before, that water vapor can absorb radiation. It absorbs infrared radiation coming from the surface. It tends to trap more heat. So in fact, the impact of the CO2 rise is kind of doubled by the increase in water vapor. So it's a very important feedback. Clouds, I could give you a whole lecture about clouds, but they have a very complex impact on the climate. And one of the key challenges in modelling the climate is actually getting the clouds right. So this water cycle obviously is incredibly important for life on the planet, but it's also very important in terms of global warming and the greenhouse effects. So I keep pointing this the wrong way. The general circulation, so if you warm up the equator and you don't warm up the pole as much, the winds will try to redistribute the heat from the equator to the pole. To balance things out, and the currents in the ocean will try to do the same. Because the Earth is spinning, actually the winds don't go straight from the equator to the pole, they actually go around as well. So that's why you end up with the kind of cyclonic behaviour that we get when you look at a weather map. It's a very complex system, and it can give rise to very complexity in the weather. So the spinning of the Earth is a very important part of this as well. But essentially, that circulation is trying to redistribute the heat. And again, if we change the balance, then we'll change that redistribution of heat, and that will change our weather. And that's why one of the reasons you get changes in extreme weather. So one thing is, because the water cycle is stronger, you're getting more rainfall in some places, and to balance that, you get more drought in other places, but also you get changes in the weather patterns as well. So, let's go this way. So what we're doing is, releasing greenhouse gases through burning fossil fuels, but also forest fires. There are many places, we talked about the Amazon earlier, where that releases greenhouse gases as well. Changes in land use have an enormous impact as well. So you can actually sequester quite a lot of carbon in the soil if you manage the soil well. So there's whole debates around how we do our farming, and I'm not sure that some things are well understood. Many things are not well understood in terms of things that can be done in terms of the land management, for example. So this is just an example, and I'm not going to go into too much detail here, of the kinds of changes that have gone into the latest climate models. So, the scientists are getting bigger and bigger computers all the time, which means they can represent more of the science, they can represent more of the detail. And the focus on improving the models has been increasing that level of detail so that you can give people more information, but more importantly, you can actually represent the real world more accurately. You're trying to model clouds, so the observations have great complexity in the clouds, much more complex than that even, and the model really simplifies it. So how can we improve the way that we do that? Improvements in the way that the currents work in the ocean, and particularly also changes in the way that ice operates in the model. Some of you may have seen that the IPCC produced a report last week on the impacts of ocean and ice on global warming, and some of the changes that they were looking at actually were more extreme than have been found before. There's more being understood about how ice is melting in the Antarctic, for example, which give more cause for worry about sea level rise. So how do we use these models? So this is an example of an output from a model, which is presented in a slightly unusual way. I get fed up with showing the same slides all the time, so I came across this at a talk I went to, actually, at the Royal Meteorological Society, where they were talking about ancient climates. So we've got, this is, goes back to the 1950s and right the way through to 2200, but then we accelerate time going backwards here. So this is going back thousands of years, so 300,000 years, and this is going back millions of years to 60 million years. So what you can see here, so we're about here, okay? And what you can see here, that by 2100, the temperature will be higher than it's been since right the way back 5 million years ago. 2200, at these extreme levels here, we're talking about 50, 60 million years. These coloured areas represent the range of possible outcomes, because we don't know exactly what's going to happen. If we have very high emissions, it could be somewhere between 4 degrees and 12 degrees here by 2300 somewhere. If we reduce emissions, obviously we can reduce that. But that just illustrates how different the world would be. We don't really know what the world was like 60 million years ago. We've got some information, but it was very different to how it is now. Without the ice caps, much higher sea level, it is a very different world. It takes, although the temperatures will go up that quickly, actually the ice would respond more slowly. So in fact, the sea level would rise much more slowly, but nevertheless, we are committing to a very large rise in sea level, for example, as well as all the other changes. So it does help to highlight the sort of changes that we're talking about. So these models are used to give us information about how we need to mitigate climate, how much we need to reduce emissions, but I just wanted to illustrate that they are also used to look at how we need to adapt to climate change. Even if we reduce emissions quite a lot, we will still have to adapt to a certain amount of climate change, so we need information to do that. And so the models that I talked about have been used, and these are results that were published at the end of last year by the Met Office, working with DEFRA and the Environment Agency and BEIS. Because obviously the work is funded by government, but this is looking at the sea level rise. So if you just look at London, for example, so this is the red area is a high emissions scenario, and you can see that by the end of the century, the sea level will have risen somewhere between 50 centimetres and 115 centimetres. We can't be sure because we don't know enough about the science to narrow that down. If we manage to reduce emissions, it will still rise by between 30 and 70 centimetres. So that's for a medium emission scenario. So that just gives you an illustration of the kind of information that you can use to help you look at the risks of climate change. And it is about looking at risk. It's not about looking at this is what's going to happen. It's saying, what are the risks? How is that going to affect me? And now looking at the mitigation. So Jacqueline talked about, what we need to do, 1.5 degrees. This is looking at a 50% chance of staying below 2 degrees. And it's looking at the carbon budget. Based on using climate models to work out what that carbon budget is, and saying that if we, so this is a medium emission scenario, if we carry on emitting using a medium emission scenario, so we reduce our emissions over where we are now, but not as much, not drastically, but quite, well, it is drastically, but not as drastically as people would like. We've got 20 years at that level of emissions before we have to stop, basically, before we run out of carbon. So this is like, you've got this hourglass thing is saying, we started off with this amount of carbon, we've already used up this much, how much we've got here. If we slow down how much we emit, then we can slow down that reduction there. If we manage to go for a low emission scenario, then we have 30 years. So this illustrates the benefits of starting early. And I've got another example here, which is another way of presenting this, which gives a bit more detail. So this is looking at the gigawatts per year of deployment. So there's deployment rates of new power stations. So this is between 2000 and 2010, if you look at the bottom. So there was 50 gigatons of coal, gigawatts of coal deployed per year on that timescale, 20 gigawatts of gas, 20 of nuclear, 15 of wind, and 4 of solar. So, the renewables are relatively small there. So if we're going to take, if we take global action now, in 2020, then if we would need to change to, we can still use gas, but we have to do carbon capture and storage. So basically what that means is that you burn the gas, or burn whatever, you capture the carbon out of the air and you bury it underground. Now, obviously, that's an inefficient thing to do. You have to use energy to do that. You also have to make sure that you keep that carbon secure. There are technologies that people use this technology for extracting oil and gas, actually. So they pump it into the reservoirs, into the spaces underground. So, there is some technology there, but it hasn't been proven at scale for this purpose. So it's a big challenge. There's another thing called bioenergy carbon capture and storage, where you basically grow biofuels and then burn them and capture the carbon. And with that, you can remove carbon from the system. And that's talking about 52 gigawatts. There are issues around that, significant issues, because in order to grow the amount of biofuel that you need to generate that amount of electricity, you need to reduce your agricultural crops for food, and or you need to reduce the amount of diverse ecosystems and grow crops on land that wasn't used for crops before. So it's not good for biodiversity. It actually isn't very good for carbon initially, because you end up releasing more carbon either from the vegetation that you remove or from the soil if you damage the soil. So in fact, in some scenarios, it can take 50 years before you actually break even. So it's not, I don't think it's a great option. You need 83 gigawatts of nuclear, and there are many different nuclear technologies out there, that need to be tested, and that's it's a whole area of debate. I know 48 gigawatts of wind and 23 of solar. However, if you wait till 2030, you can see these numbers are much bigger, because you've already used up a lot of your carbon budget. So you have to do a lot of these things that are going to help you reduce carbon use much more effectively. So it's much more challenging. So, having talked, we've really focused on climate change here, but we need to look at this in the context of the Sustainable Development Goals. Whenever you make a change to improve one aspect of the environment, if you don't take account of that impact of that change on other aspects of the environment, on the social impacts, it will have unintended consequences. And air quality and climate change in the UK is quite a good example of this, because the government decided 10, 15 years ago that it was a good idea to promote diesel cars because they produce less carbon. But unfortunately, they also produce more particulates, which have a big impact on air quality. And that's having a big impact in the cities. For example, in London is a good example. Of course, they were guided by manufacturers who told them that they could do something about it, about the air quality problems. But it does illustrate how you need to look at the end-to-end solutions, how much, for example, concrete are you using in a wind farm, or the impact of this new gas that you're producing that's better than carbon but might have other impacts. So, so this was just an example of, with air quality and climate change, you can do some things that are good for air quality and climate change up here, some things that are bad for everything, you don't want to do those, some things that are negative for one and positive for the other, but you want to be in this space here. So by looking at this in this kind of way, in this holistic way, it allows you to look at those things. And I'll stop there.
Welcome all, and welcome to those listeners online. The first thing I'd like to say is I'm not a scientist, I'm a social scientist. Socio-legal scholar, I think, is perhaps the best way of describing me. One of the things I've been working on recently is the potential for a crime of ecocide being enacted in the international arena to help curb some of the problems that we are looking at within this notion of the ecological crisis. But before I get into that, I'd like to just put it in the context of other aspects that I've been working on recently, which is looking at energy policy and the limits to growth. So first of all, if we look at things like emissions, we have to also appreciate the role of the economy, technological change, and then also energy prices. Now, these are the things I've had to look at recently when I'm looking at unconventional energy. I'll come on to that in a bit, and the role that plays in our current predicament. So the limits to growth is a very famous study from the 70s. It's recently, well, I say recently, probably about 5 or 6 years ago now, there was an update to that. It wasn't particularly well publicised, but it basically demonstrated that all of the dire predictions in the limits to growth were unfortunately coming true. And one of the things that we can see as sort of proving that, in a sense, is the move from so-called unconventional energy sources towards, from conventional towards unconventional energy sources. And one of the things that we really need to do is to make sure that we analyse those unconventional sources and look at them as potential solutions on one hand or problems on the other. And one of the things that we should consider when looking at that is the risk to people, to the environment, but also look at how efficient they are. We can certainly see in terms of what's happened with these developments, mountaintop removal, drilling deeper and deeper in the oceans, the boreal forests of Alberta being turned into what some people have called Canada's Mordor, which is a rather grim way of looking at it. But if you look at the online pictures, you can sort of understand that. And then onshore fracking in countries like the UK. Now, one of the things that we've looked at as social scientists is exactly what sort of implications that has for us going forward. And we've come up with this description of extreme energy as a process, whereby, in effect, we go for the easier stuff first, and as that starts to run out, we go for the more difficult energy resources. One of the things that we've found is that extraction effort, in other words, the effort it takes to get these resources out of the ground, it strongly correlates with damage to both society and the environment. So we've described it as a process whereby you get the easy stuff first and then you go after the more difficult stuff. And one of the implications for this is that the more energy you use in the process, the less there is for society to use. So the bigger the red circle goes, the less we get for society to use. Importantly as well, though, it's interesting to look at the energy efficiency of these things. And industry doesn't like to talk too much about how efficient it is. So the more energy it takes to get it out, the less efficient it is overall. For example, a conventional oil well over the years would have been 1 barrel of energy in to like 60 to 80 barrels of energy out. Something like the tar sands in Alberta, Canada, is 1 to 6 or 1 to 8. It's radically different in terms of the energy efficiency. What do climate scientists say about this drive towards unconventional energy? Well, they're quite unequivocal about it. James Hansen says, we must leave unconventional fossil fuels in the ground. Kevin Anderson also, again, the keep it in the ground idea is quite strong here when it comes to unconventional because it's so less efficient. So one of the things that I was looking at in the context of all this is the whole idea of growth itself. Now, we're often told that, growth will make us happier, etc., and energy is dependent on this growth. And, we have to now question this whole idea. Has, in fact, energy producing growth over the last 50 years made us, in fact, happier? Many studies we've looked at recently are saying, no, it hasn't. So why are we doing it? It's a very, very important question. And one of the byproducts of this drive that we've had for increased growth over the last 50-odd years has been huge, what industry would call externalities, all of the negatives that are associated with our dependence on fossil fuels and dependence on a growth-driven economic model. It's massively increased our ecological problems. So one of the things that we've looked at over the last few years as social scientists and what we call the green criminologists, a new thread of criminology, which is really interesting, that's looking at criminalising things that may currently be legal but which are harmful to people and the environment. Now, and I worked with a wonderful lady who some of you may know, Polly Higgins, who unfortunately passed away this year, on the whole idea of making ecocide what she called the fifth crime, or the missing fifth crime against peace, to stand alongside genocide, crimes against humanity, war crimes and crimes of aggression. And we worked together because I was working on genocide studies at the time. And what I've learned through the history of genocide in the UN system is that you can have a very strong and robust idea, like Raphael Lemkin had with genocide, and when it works its way through the international arena and the political debates that take place, it tends to get watered down. So she had this great idea. One of the things I was doing was saying, well, actually, we have to think about how it'll be politically diluted. So it was a very important question to think about, how we pitch this to the international forums. But nonetheless, I still saw a lot of potential in the idea because these are the current issues that we're facing. Peaking resources, drive towards extreme energy, which some climate scientists have said to me is tantamount to sprinting in the wrong direction. because it's so inefficient and environmentally destructive. Anthropogenic climate change, and it's not just about carbon, it's the ecological crisis as well, including things like species extinction. So could ecocide solve all those problems? Well, my work on the Genocide Convention would suggest not, but it's a potential to be a vital tool in a toolbox. Basically, the idea was that we'd have to amend the Rome Statute, okay? Another big if, but not impossible. It would require a member state to table it at a review conference. But what it then could do is it could make things like the tar sands in Canada illegal, okay? And that's sort of one of the poster childs of extreme energy because it's so grossly inefficient and it can be seen from space. And this is something that Polly Higgins was particularly passionate about. And her idea of ecocide, to quote, was the extensive destruction, damage to, or loss of ecosystems of a given territory, whether by human agency or by other causes, to such an extent that peaceful enjoyment by the inhabitants of that territory has been severely diminished. There was lots of discussions about this definition, etc., and I tend to sort of say ecocide really is the destruction of ecosystems, and a lot would depend on how this was thrashed out to turn it into a law. But one of the things ecocide as a crime would not do, and this is something that I've seen in my own work, is challenge the whole idea of consumption. Because it's, in many respects, it's one of the sort of under-discussed elements of our carbon footprint. And I was very interested to see this data. And it does vary depending on what you get the source, what sources you use. But the International Energy Agency has produced this table last year. And it's particularly interesting. We hear it often said that China's our problem or India's our problem. If you look at the per head of population figures, I found this as a sort of social scientist really interesting. And you can quite clearly see that developed countries are considerably more responsible than the less developed countries if you look at it per head of population. And then it's hard to find this, but if you break it down further, and this is an example from the US, it's interesting to look at what part of that is made up by what Annie Leonard has wonderfully called stuff. In other words, buying consumables. And I think this is one of the most under-discussed elements. You know, we hear discussions about heating our homes and transport, but what about buying things that possibly we don't need? And I think this has to be part of the discussion about how we solve our problems going forward. But of course, why isn't it? Because it's part and parcel of a growth-driven economy. But it's a wonderful video. I suggest you all go and watch it if you haven't seen it. It was done as it rightly should be for a mass audience. It's very easy to understand. I showed to all my students the story of stuff by Annie Leonard, and it comes out of a book as well. But it's a very, very important question. What do we do about that slice of the pie? Okay, how does that fit into our economic model?
I was sent the question how to avoid a climate catastrophe, so perhaps I should start with a confession. I stared at the computer for about 3 days, working out what my response should be, because I'm a psychologist and I think that the problems are a little bit quite complicated. Okay, how do we avoid it? Well, we need a green revolution. Jacqueline talked about the revolution we need. We need a change in political focus in politics, change in infrastructure, but we need a change in people in terms of their behavior, their choices, their priorities, how much stuff they need. These are absolutely critical. People are the key. And of course, therefore, I would argue psychology is central to the whole argument. Now, climate change, you don't need me to say that the scientific evidence is overwhelming. We've heard a lot about that. Remarkable scientific consensus, and of course, it's already been made clear what the threat here is. So the question is, why hasn't the message got through? And I would say the message hasn't got through at a number of levels in terms of ordinary people's understanding, their beliefs, their sense of personal vulnerability, their sense of personal responsibility, and critically, their behavior and action. What I'm going to say is there's often a big gap between what people say, the discourse, and what they actually do. And I want to talk about that. There's Greta saying, can you hear me? Well, we can hear her, but the question is, do we understand exactly what the implications of it all are? So in terms of understanding, this was brought home to me recently. I was on a bus in Sheffield. I had a notebook on my lap, and I was writing something about climate change, and it was in bold capitals with an exclamation mark. And the guy next to me nudged me and said to me, well, that's bloody rubbish for a start. And I said, why? And he said, just look outside. And it was a very, very light snowing very, very lightly. I didn't respond because it's often been pointed out like climate change is like politics and death. You don't discuss it in polite conversation anymore, and certainly not with strangers on buses. So I just sat there. He got very angry because I wasn't responding, and he said, "You don't believe any of that rubbish, do you?" And he was asking everyone on the bus to join in this condemnation of this man with a notebook that said "climate change!" exclamation mark. So there does seem to be a bit of a confusion in some people's minds between the weather and climate. Donald Trump, of course, is someone who famously confuses the two. He was in Florida in December 2017. He said it could be the coldest New Year's Eve on record. Perhaps we could use a bit of that good old global warming. So the weather was bad, but not necessarily the climate wasn't changing. In terms of belief, some research from Yale a few years ago, 52%, half the people in the US believe that global warming is happening. The figure fluctuates with economic conditions and other factors. 50% thought that global warming, if it does exist, was attributable to natural causes. So there's clearly an issue there about belief. In terms of what differentiates believers and non-believers, there's faith in understanding of science. The IPCC use terms like extremely likely, which means 95 to 100% probability. And critics point out, well, it's not guaranteed, it's not certain, like death and taxes. Death and taxes are certain. Climate change is probabilistic. Political and ideological position. In the US, about 50% of Republicans and 88% of Democrats believe in climate change. At one point in the past, there was much less divergence, and the divergence happened after the Kyoto Protocol, when the economic implications of climate change became clear, and suddenly there was a whole surfeit of anti-climate change books and articles. It depends upon education, age, social class, etc. But it also depends upon individual psychology. And this is what's really interesting, the differences between people in terms of what they understand about climate change and their propensity to action. Now, this connects to this concept of personal vulnerability. When you hear the evidence, now I've been, I'm sure, as impressed as everyone else by the talks I've heard so far, you know, and it's absolutely crystal clear that there is this existential threat, but not everyone gets it. And one reason is, unfortunately, human beings are a ridiculously optimistic species. Ridiculously optimistic. As Jacqueline said, they're about bystander apathy. Well, that's one aspect of it, which is someone else will fix it. If it's serious, someone else will fix it. Now, one aspect of optimism is called the optimism bias, where people estimate the probability of positive events. And it's reckoned that about 80% of the population really suffer from this optimism bias. So if you ask people who are just in the process of getting married, as some psychologists do, they're walking up the aisle, you stop them, and you say to them, do you think your marriage will work out? They say, yes, it will. Geoffrey, it will. How sure are you it will work out? Oh, I'm 95% certain. Here's the divorce statistics. That doesn't apply to me. It's other people that applies to. Individual smokers think they will be the ones who won't get cancer. Some people are more extreme in this respect than others, and we call those people, surprise, surprise, optimists. In terms of personal vulnerability to climate change, people think that climate change will affect other places, it's called spatial bias, and future generations' temporal bias, rather than they themselves. And of course, this is a form of a defense mechanism. But it's a very interesting defense mechanism because it connects to how we respond to information. Jacqueline talked about all the messages out there, but let me draw attention to one worrying aspect of that. Now, in terms of how we process information, people put participants in a scanner and asked them to estimate the probability of certain events taking place. Then they told them the real probability of the events, and they said, guess again. Incredibly, the accurate information only affected their judgment when it was better than expected. If it was worse than expected, they didn't change their estimate. And even more interesting, when you put people in a scanner and do this, there's a bit of the brain called the right inferior prefrontal gyrus. It lights up when the information's good. We love great information. So in other words, optimism bias is characterized by selective information processing. Now, a person in the front row, we did a little experiment on this a couple of years ago. We asked people to read climate change messages. So they read articles online, and some of the arguments were for climate change. That's bad news, right? The 4 arguments are bad news. And against climate change, oh, the science might be wrong. That's good news in terms of our brain. And these were in adjacent paragraphs. And I tracked people 25 times a second as they read these articles. We measured their optimism level. And you end up with something that looks like this. So in adjacent paragraphs, there are arguments. In this case, the first paragraph's against climate change or for climate change. On the left, it's optimists. On the right, it's non-optimists. Now, a number of the red bits show the fixations. The deeper the red, the more the fixations. Non-optimists, have a guess what they do? They read climate change articles really carefully. What do optimists do? They skip over them. And really interestingly, they spend less time attending to any arguments about climate change. They have significantly shorter fixation durations than non-optimists on arguments for climate change. When they read the article, they focused on the good bits. They skipped over the bad bits and therefore stayed pretty optimistic. When we asked them to summarize it, what was really interesting, 2/3 of the non-optimists said this article is about global warming, blah, 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 blah. They kind of got it. The optimists, on the other hand, said, hey, it's a debate. It's a debate. There's arguments, counter-arguments out there. When they read it, they said, yeah, I've got a debate. When you ask them about their personal vulnerability, also really interesting. They reckon that climate change will happen one day, but ask them about themselves. Optimists reckon 36.5% probability, but 1 in 3 of being affected. Non-optimists, more than half. So huge individual differences connected to dispositional optimists. And I'm always reminded of the fact that entrepreneurs, of course, the single personality characteristic that characterizes entrepreneurs is optimism level. So it'd be interesting knowing how business people, think about it. Anyway, implications, messages about climate change may not be getting through because of an inherent cognitive bias designed to sustain our mood state. So we need to think about a more positive frame, and in order to increase feelings of self-efficacy, in other words, the feeling that you can do something about it, and attention to the underlying message. Now, the next question is our sense of personal responsibility. We've known, and Damian's talk was very clear on this, the stuff we do in everyday life, what we consume, our energy, etc., affects climate change. Some big businesses have got the point. Unilever famously in 2010 announced their sustainable living plan, announced a whole series of things they were going to do to reduce greenhouse gas emissions per product across the life cycle by 2020. They went to a lot of trouble to do that, and what they found was the greenhouse gas emission footprint impact per customer increased. It increased. So all the stuff they did in the manufacturing chain to reduce it, it nevertheless increased. And they said we've made good progress in those areas under our control, but the big challenges of those areas not under our direct control, like consumer behavior, it's what people do. And there's all kinds of things that puzzle them. They couldn't work out why people have such long showers. And I gave a talk on this to students recently, and I asked them how much time they spent in the shower. I spent about 2 minutes or 30 seconds, right? I started off like in a ironic way, saying, does anyone spend more than half an hour in a shower? And all these hands went up. And I thought, oh my God, I need to do a different benchmark. 45 minutes, about 30%. I thought, so some extraordinary results. Anyway, could we make it easier for consumers? Well, this has been tried. Terry Leahy in 2007 said, look, all we need to do is put labels on products. And then consumers will see what's high carbon and what's low carbon. They'll opt for the low carbon. This will change the market. It'll move everything towards a lower carbon economy. And of course, the reason for that was it had worked for health information, fat information, calorie information, food. So they put carbon labels on products. A lot of numerical information. Huge undertaking. Tesco planned to label 70,000 of their own brand products. Several months to calculate the carbon footprint of each. Blah, blah, blah. How did consumers actually behave? They didn't opt for the low carbon alternatives. And we did some research looking at people, again in an experimental situation, looking at labels. What else didn't they do? They didn't look anywhere near the carbon label. If you look at about the first 5 seconds of looking at a product, that is the time to actually choose a product, they looked at the carbon footprint first in about 7% of all instances. It was of not much interest. And that gets us onto this really, really big issue, which is the value-action gap, which is shown in many aspects of environmental behaviour. And there's a lot of faith put upon young people to sort everything out, and there's been a lot of amazing stuff happening in terms of single-use plastics, etc. And yet, these are from two festivals. This is the Leeds Festival. This is what was left behind at a recent festival. And this is the Reading Festival. So, obviously people say they don't like plastic, blah, blah, blah. Why would you pollute the world in this way? But in the priorities of life, when the tent gets muddy, blah, 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 you leave it behind. So there is this big, enormous gap between what people say and what they actually do. Now, I've got really interested in this question recently because it seems to me central to this whole climate change issue. The way psychologists try to measure this is they measure something called an attitude. And an attitude is a mental and neural state of readiness organized through experience, exerting a directive or dynamic influence upon the individual's response. So it's a mental and neural state of readiness. And that definition comes from a guy called Gordon Allport, 1935, the founder of social psychology. So basically, when you measure attitude, you ask people to say what their attitude is. And when you do it towards low and high carbon, it's not surprising what you get. 70% of people say they prefer low carbon, 26% no preference, 4% say they like high carbon. Interestingly, that's what they say. But Allport also said often an attitude seemed to have no representation in consciousness other than a vague sense of need or some indefinite or unanalyzable feeling of doubt, assent, conviction, effort, or familiarity. Now, to me, that's a really interesting question, because if we're trying to make behavioral predictions about climate change, are we really in touch with people's underlying real attitudes, given how complicated it is? Now, there's been a lot of work done on this by psychologists in the last few years, and one way they're trying to get at it is to measure what are called implicit associations, which is based on a reaction time task to measure associations in the brain, in this case between low or high carbon and concepts of good or bad. It's just based on a speed task. You don't report your attitude, and you end up with a little computer task that looks like this. Now, when you do that, you get something very interesting, which is, first of all, the measure you get from this implicit association test doesn't correlate with what people report in this domain. So in other words, there would seem to be many surface greens in the world, certainly in our societies, with a reported positive attitude to low carbon, but actually a positive implicit attitude to high carbon. Now, why would people have a positive implicit association to high carbon? Well, it's the psychology of stuff that Damien was talking about. We've been brought up in a consumer culture, fed decades of advertising to get us to like all that stuff. It's part of my social identity. How do I get liked on Facebook? I have to wear a new outfit, Damien. I have to go to Primark. Sorry, I'm talking from the heart here. I have to go to Primark 4 days a week to buy new stuff to wear. Sorry, the old thing won't do. And we buy all this stuff. And sorry, I nearly said, sorry, yeah. I was going to say, and it's just bloody rubbish, but you can't really say that because it's like I'm talking about a shop. Okay, right. So anyway, what I'm saying is the psychology of the surface greens, understanding these conflicted individuals may be critical. They may be very common, and they've not been identified as a group thus far by DEFRA or anyone else. Now, in terms of attitudes and behaviour, we know already that both explicit and implicit attitudes do predict behaviour to some extent in different domains. The IIT is a better predictor of spontaneous behaviours when behaviour is under cognitive, emotional, or time pressure. A lot of shopping is exactly that kind of spontaneous behaviour under some kind of time pressure. And it's a much better predictor of behaviour in sensitive domains. Famously, the IIT has been used in the racial domain to look at racial prejudice and how it's executed in everyday life. In our own research, we have found that implicit attitude to carbon footprint predicts choice of low carbon products under time pressure. It predicts unconscious eye fixations on climate change images. When we measure implicit attitudes, if you show people climate change images, they're more likely to look first at those images. Explicit attitudes, what they report, doesn't allow you to do that. And of course, when you think about implicit attitudes, and then as a new way of measuring human behaviour, it gets you to think differently about the value-action gap, which is there a gap between what people report and what they do? Well, maybe not, if they've got these implicit attitudes. And recently we've done some work showing that you can, it's just online at the moment, it'll be out next year, showing that you can change implicit attitudes using certain types of techniques. And weirdly, it's not the first time, of course, the unconscious has been recognised by people interested in behaviour change. And the example I always like to give is the smoking literature. When you think about smoking, wasn't it, in retrospect, unbelievable that they got so many people smoking through sophisticated campaigns, in which led by this guy, Ernest Dichter, and his notion that you have to assess unconscious motivations and change those. He said you can ignore what people say. They don't know why they're doing stuff. And I keep saying, if we can get people to smoke, we can get them to do anything. So that's why I'm optimistic about all of this. So encouraging the green revolution, we need to help people, we need to help explain the science better and clear up conceptual confusions. Climate change messages must be designed to overcome optimism bias. We cannot just scare people. Greta Thunberg is incredibly impressive, but telling people the house is on fire, unless you're telling them exactly what to do, people's behaviour in fires isn't necessarily the most rational, so we have to give them a little bit more advice about what they can do. We need to increase people's feeling of self-efficacy and response efficacy when it comes to their actions. They are crucial to making a difference. We need people to think that they can actually do something. They personally can do something. Self-reported attitudes to carbon might lull us into a false sense of security. It's been far too much surveys done saying that people are ready to change, they're ready to be mobilised. Extinction Rebellion is the tip of the iceberg, but the body of the population are behind them. We need different kinds of measures of that. And we need to understand that many people have implicit and explicit attitudes to carbon that are dissociated, that simply don't connect. And we need to find new ways of identifying them. And therefore, we need different strategies for different groups and countries. The barriers will be different. Part of what we've been doing recently is looking at government campaigns about behaviour change in the light of climate change, and with the view that there are underlying emotional connections to high carbon lifestyles and stuff, then you'd think most of those campaigns have simply got it wrong. So encouraging the green revolution, what do these individuals see? What do they attend to? And the critical thing is we need to work on changing our implicit attitude to carbon products and lifestyle by influencing our underlying associative networks. In terms of consumer culture, it's been done for decades. We're most of us are wedded into this notion of this kind of deep emotional connection with stuff. And so what kind of campaigns do we need to think about that's going to change that, and it's going to produce genuine changes in implicit attitudes, which will have a dramatic impact on behaviour? And the smoking industry showed that such a change is possible with significant behavioural implications. It's one legacy. And if anyone's interested, we did a little book called The Psychology of Climate Change. Bit of a plug.